Without further ado, it is my great pleasure to introduce our first speaker today, Professor Fridolin Wild. Fridolin is a professor at the Institute of Educational Technologies at the Open University, and he also heads the Performance Augmentation Lab. He will talk to us today about augmenting human performance at scale. Welcome, Fridolin.
Thank you, Leah, and thank you, Leonardo. Yes, it's my great pleasure to speak to you about something that is close to my heart, and that is how we improve human performance and how we do that with instruments that scale, where we're not investing more time in gearing up for the experience than we can actually then deliver in hours. I thought I'd start here with the kind of social context in which this all happens. Shift happens. We live in a time in which several events have impeded on our life. I think even neglecting Brexit and the pandemic, the most significant one and more enduring and longer lasting one, I hope, is the automation that we're currently facing over the last decade or two even. And that seems to be accelerating, in which robots, algorithms, machine learning take over more and more of the jobs that previously would have been executed by humans. That causes further shifts. That causes a shift in mindset. We are more prone to lifelong learning than ever. We create new types of jobs, hopefully. In manufacturing, for example, that means new collar jobs are emerging that are in between white and blue collar, gray collar maybe. IBM speaks of new collar. And that then also goes down up the line in the organizational structure, so that we have more matrix-oriented network structures, that we have different C-suite management positions, and in general, that disrupts the workplace as we know it. And maybe with this pandemic, with this black swan that we're facing now, we have a chance to get things right and change them around. Humor yourself. Follow the link to some work from Oxford University, from the Future Institute, where colleagues investigated which jobs are particularly at risk of being replaced. No one is safe, even my job. See here, that's a photo from a colleague who took one of his robots to the BBC a while back to present something, in that case, a comedy. Nothing is safe, but some jobs are more likely. At the same time, that doesn't have to be scary. That's life. That has always been life. Automation is always disruptive, and if we play it well, it creates new jobs along the way. And at the same time, we also have the technologies now at hand to train and educate in significantly different ways, as you see here in front of you. So smart glasses are on the rise, on the horizon. Some of them slowly getting into a field that is affordable for consumers. Other accessories like smart armbands or wristwatches are there. Others are coming, maybe smart gloves. And if I predict the future right, an exciting future awaits us with regards to further innovation on the textile front. Fabrics that have embedded silver threads and become conductive, so you can interact through them, or that have the ability to provide you direct haptic feedback and things like that. And many other technologies are on the rise. So overall, augmented humans are closer as a vision than ever before. And that allows us to tackle this fallout of all the disruptive events that I just mentioned. In the field in which I'm also active, educational technology, this is now the fourth revolution, if you want, where we have gone through a couple of waves before, the kind of digitization wave, the scaling wave, where the web was also invented, to the personalization wave, where we now have a wave in which we're effectively cutting out the medium and place things in the real world by delivering directly onto your skin or in front of your eyes. That's a wave that I call a wave of disintermediation, cutting out the middleman, or signified also with one application area that I like to call performance augmentation. Yeah, so let's look a little bit deeper into this. If we look at the technologies at hand, smart glasses, Probably every one of us has had some sort of experience with these type of glasses, the kind of Google Glass-like ones, where you have a little information display in the corner of your eye that can directly show you some incoming email or a sender value read from a machine. Not terribly exciting, but useful. We have maybe even been pained by something in the community, people call it bird's nest. Cardboard slot in where you put a mobile phone in, then through a system of reflective mirrors and lenses, you get something like an augmented reality experience overlaid on the real world. What is not so popular yet, but is coming, and that is the big revolution I predict in personal computing, that is waveguide displays and on the horizon laser beam scanning. These devices are like here the flagship in amongst the products in Microsoft HoloLens, are capable of delivering something that is unprecedented, that is a completely different experience where you actually see something in the room with you rather than looking at it through the window of some sort of device. Smart textiles also are going through revolutions. We've seen a lot in the accessories space where you have electronics components that are just mounted on textiles as a carrier, or at best with integrated sensors, but there is more possible. One of my lectures that you will find online speaks about how you could build a complete computer completely out of textiles, and that then also allows us to take stock of developments in the textile space of possibilities that we otherwise wouldn't have, stretch fabrics, for example, that have very interesting components, enabling completely new applications. Another big enabler technologically is the new facilities for reconstruction. And I think that is particularly relevant to encapturing and encoding heritage. The technologies to 3D scan in real time, as you see here in front of you with the video from Pearson Interactive, now sold off to GeekXR, is quite amazing. So that is still quite expensive in the quality that you see here in front of you. The studios typically have over 100 cameras that are mounted together with good lighting systems. The kind of consumer grade space that you see here on top, an iPad clip-on, is catching up rapidly. And algorithms that formerly were computationally very intense can now be delivered through cloud technologies directly to small devices. That enables us to very quickly, for example, copy a body backup of a person. That's from my own work that you see here from the HoloCare project, where we captured a fitness instructor or two to deliver workout programs to cancer patients, cancer surgery survivors, for helping them with rehabilitation. And that's effectively a couple £100 device. And more is on the horizon visible for how we can create this mimesis of the real world. New digital twin technologies we're helping to develop, or other sensors that can do the same things as this here, even cheaper with just video cameras. To come to the end, I think, of my technological analysis of what has changed and what do we need to take into account when we're entering this new age of disintermediation, that is certainly responsiveness. That the modern augmented reality and also now virtual reality devices catching up are capable of responding to the real world and events in the real world. Here you see, for example, a screencast from an iPad in this room behind me that maps the environment in real time and is able to respond also, with the right algorithms applied, to furniture standing there or things changing in that environment. Moreover, it is possible with that responsiveness now also to take stock of lighting in a way that allows us to deliver illusions that simply work. Where formerly we couldn't quite make out necessarily, where formerly we could quite well make out whether something would be a digital overlay or the real object. This is, especially for video see-through devices, now becoming quite possible, as you see in front of you. So that's the virtual mannequin. That's the real mannequin in this film.
Okay.
We make use of this to augment human performance for a couple of years now. We have built, for example, an application.
Okay. Take the scissors
not yet a decade ago, but getting there.
Then
to
cut the threads.
Deliver remote instruction to trainees through the use of ghost hands. So we used at that time a simple hand scanner placed in front of the desk of an instructor who would observe the point of view video of the trainee to live guide the trainee through procedures. And that was terribly engaging and very exciting, and has led us then to scale things up and move things forward over the coming years till today. And I'll just quickly show you an insight into the training tool Mirage XR that we are developing in my lab together with a couple of institutions across the globe. Where we have taken this idea of ghost hands a little bit further to create replica ghosts of the expert doing things. Here you see an instructor showing in a hospital setting how certain observations have to be done on a patient, how drip feeds have to be delivered, and we also do this with the help of very quickly produced overlay glyphs, a kind of visual language for movement and handling, and character models that can deliver instruction in speed of the expert. So the character model you've just seen can walk and talk, can also animate a few things, and we're at the moment working on reintegrating into the product version a way to interface with real artificial intelligence dialogue understanding, so you can have a more free flow conversation with the artificial intelligence. Yes, jump over that. We've seen that already. That's from earlier work. An earlier version of the Ghost you have just seen, not as fancy in design, but here in a different setting, used for training astronauts in a Mars surface simulator in Italy at Project Partners. And yeah, overall, training technology is there. Things are very exciting, and they work for a variety of reasons. And let me just come to a conclusion with that and summarize them. They work, in my opinion, because augmented reality and the whole technology space that opens up through that has gone away from this object-centric view, from overlaying something on your Coke bottle, to a more embedded view in reality that is activity-centric, where support is given for real tasks, where it's not just an entertainment gimmick or a marketing thing, but it's something that enables performance and step by step. So this, for example, we have broken down in a range of publications on instructional level. This just means supporting for actions, supporting for the task itself, giving additional support, and allowing for practice. That's one of the key reasons, I think, why augmented reality is becoming more important, because it becomes more embedded and more encompassing. It is also for the reason that we have the content models now, and content is king. Many of you may be aware of this dancing baby. This was actually one of the demo files that shipped for character model animation with 3ds Max in 1999, and since then have had many guest appearances, even in film. Sex and the City, need I say more. The one that I'm chairing at the moment to develop and further develop is in the IEEE, is a model for augmented reality experience models. One could even say that the learning is not necessarily in the foreground. It works for all sorts of experiences. This is a standardized way of describing these activities and the interaction with the media elements that overlay on the real world. Also describing the real world in a way so that it becomes more interactable. This is, technologically speaking, also not a question of a single tool and a single application, but something that fits into the wider landscape of tools that are typically supported in an enterprise landscape. So, for example, here you see that the core layers of the system we're developing. You see the app layer and then some services and databases behind. But on the right, I think quite notably, you see what other types of systems are involved typically in when you create on an industrial scale such an augmented reality experience. Yes, I invite you cordially to try it out. We have released Mirage XR now in version 1.5. 1.6 is scheduled for in about a month's time. And if you watch this as a recording, it may have already happened and further versions may have gotten out. It's available not only for smart glasses, HoloLens 1 and HoloLens 2, but also for iOS and Android there with a slightly more flat user interface where it's needed, but nevertheless having the same capabilities as with anchoring content in 3D space and guiding users through real world activities from place to place, from task station to task station, delivering them instruction where they need it. This is the beginning, I think, of a journey. Technologically, we're on a level where the revolution is bound to happen, where we move personal computing from the previous breakthrough generation of smartphones to something where we can deliver instruction in place, where we can use reality as a medium, where we can get rid of the constrictions of screens as we know them. And that, of course, opens many other questions, also in this context of preserving cultural heritage, and maybe in particular with opening up new avenues for looking at intangible cultural heritage like performances. Thank you.